So a while back, I actually got a request to cover some properties of basic addition. And while that's in a lot of your textbooks in the first couple pages, there is this interesting idea in Calculus by Spivak that asks, what if 1 plus 1 were 0? What if we defined addition like so, where we only consider two numbers, 0 and 1, and where adding two zeros gives us a 0, adding a 0 and a 1 gives us a 1, and adding two ones gives us a 0. Now, what's interesting about this problem is it makes you think about what properties of numbers matter and why we define numbers the way we have. So one of the most important properties of numbers is this existence of an additive identity. Now, the way we've defined addition, we're good, right? If we add 0 to either 0 or to 1, we still have our 0 or our 1. So that one's proven. And now you'll notice that this is going to be kind of a theme here. A lot of the things that we need to show, we can show. For example, if we want to show that addition is associative, as in you can put your brackets wherever you want, we're still good here. Now, you could go through this and do all 8 possible configurations of A, B, and C. Or you could also just notice that if we add two zeros or two ones, we're toggling to 0. And if we add the alternative, we're toggling back to 1, right? So in any case, our addition is associative, but you definitely can go through and check that out case by case if you'd like. Now, another property of addition that we need to show is the existence of an additive inverse, right? So something that I can add to my A to get a 0. So to show that, you need to show that for all A, there exists some B such that I can add them together and get 0. Now, since we only have 2 possible choices for A, 0 and 1, we just need to consider both of those cases. So if I take A equals 0, I'm done. I just take B equals 0 and 0 plus 0 equals 0. That's my additive inverse. And similarly, if I have A equals 1, I can just take B as 1 and then I'm done as well. My additive inverse, 1 plus 1 is 0. So another one that we can show pretty easily is that addition is commutative. So it doesn't matter which order you add them. Your two numbers, they're going to be the same. But if we just look at this quickly here, right? Doesn't matter what order we add 0, and it doesn't matter what order we add 1s. So, because both of those cases we're going to get, 0 and 0. And then if we look at our top right square and our bottom left square, if I add 0 plus 1, I get 1. And if I add 1 plus 0, I get 1. So in both of those cases, I'm good as well. So you might wonder, okay, why don't we define numbers like this? Everything seems to work. I'd make counting a lot easier. What's missing? And this is the big guy here. You can't show that we're closed over the positive numbers, because we're not. If A, B are positive, right? So they're from 1 to infinity of the positive whole numbers. We need to show that A plus B is positive. And in this case, it's not, right? 1 plus 1 is 0, which unfortunately is not positive. And then we're done.